fun fact of the day. He's from my hometown.
Never heard of him.
Yeah, I know. Of course you did. You watch Canadian football? You that in tune
to it? No.
Right.
Football right. Boring. Hockey
we only watch Canadian football even in the States when the NFL was on strike. And then we're like, oh, damn, there's a guy named Warren Moon who was a pretty good college quarterback in the States that's like blowing up in Canada. And of course, Warren Moon comes to the NFL and becomes a Hall of Fame player. But it's like, we didn't know anything about Canadian football. Australian rules football, same thing. We saw it on ESPN during the NFL strike. Like, that's really cool. Like, where did this sport come from? Like, we didn't know anything about that stuff, man. Nothing about it. Yeah, Canadian football.
Yeah, I remember the hearing about Warren Moon coming up from the States, and I think he played for Calgary.
I forget.
Well, don't let me stop you. You're obviously having a great time.
Yeah, I'm outside. I'm telling my son not to give me this freaking lighter, this long, this long lighter that I used to light the smoker up and stuff. Sit down, have a seat, relax. Cabin fever here in the States too. Like, goodness gracious.
Oh, it must be crazy.
Oh, I still have to work every day though. Thanks a lot, And okay, so I'll give you. We're not live right now, are we?
Yes, we are.
Okay,
yes,
well,
we are.
Okay, I won't curse, but you got people that I work with that will take the soap dispensers. I won't say who I work for since we're live, but take the soap dispensers out of the dispenser, throw it in the trash, take a picture. Oh, they don't have soap here at work, and send it to the union. I mean, we have a station where you have these really good hand sanitizers too, because they're liquid, they're not gels.
Right.
And we have it set up for people in gloves and some masks and stuff. Don't take your rubber gloves off and throw them on the counter. That's the sanitation station, guys. That's no.
Wow.
No.
Yeah.
We don't put paper towels in the sink and then turn the water faucets on and overflow the water because everybody's afraid right now and doesn't want to work anyway. Like, come on. I was sick already. We've talked about this. February 27th. I have the diagnosis. I had pneumonia. Like, what? Pneumonia? There was blood coming from my nose. My nasal passages was leaking into my lungs.
That's
I
not
feel
normal.
fine. Okay, but there's blood in my phlegm. Okay, that is an infection. I got an antibiotic and I posted what it was. A day later, it cleared up and I'm back and I'm fine. People are getting sick though, and they're getting really sick. So just take care of yourselves. Yes, wash your hands. That cuts down, at least from the CDC, 47% decrease rate in catching a virus if you wash your hands properly. Sure, we should do these things. Anyway.
My boss had it in January, and I had it in January too, because his niece came up from San Francisco, and his niece, his sister, works as a highfalutin person in business, and she's going here and meeting people everywhere, and definitely from China people. She lives in Chinatown, like San Francisco, right? So. Mm-hmm. I think I was already exposed to this Wuhan virus.
Yeah, we probably all were.
Pneumonia.
Maybe.
That's
my cousin.
I've been doing the same exact thing.
My first cousin's a cell biologist, and he, I forget what company he works for now, but he's a cancer researcher. He's a lab guy. And, he made it real easy for laymen. I talked to him on the telephone. He's in California. He's on lockdown and stuff.
Right.
And a friend of mine, we went to college with, he was also had pneumonia back at the same time I did. That is how coronavirus has already existed. It already has.
Well, yeah, it's a family of viruses.
Yes. So
the cold is a coronavirus.
This is a new strain. So what happens is your immune system sees this new strain, and it's not the old strain that your grandparents had and your parents had and we've had. So your immune system goes, "Hey, how you doing? Welcome." I know you're a foreigner, but welcome. And it does nothing. It does nothing. And then it starts to replicate. Then your immune system goes, wait a minute, somebody's here illegally. We have to do something about it. Oh my goodness, now there's millions of you. It's replicated already. Now it depends on your immune system, what other conditions you may have, etc., as to how your body's going to fight this off because it's new. And
if your body is if your immune system is hyperactive, that's when you get pneumonia.
Yes.
That's your body trying to expel the virus through the fluid production.
Yeah, but then it starts to rot something. That's when that comes in, I think. But
yeah, and we nobody we know.
Well, initially that's what it does.
You get pneumonia in one lung, and usually people get through it. 2 lungs with regular general pneumonia is when it's bad. Okay, you have pneumonia in both lungs. It's going to be a struggle. Your immune system does nothing. You feel fine, and then you have what we would call, layman terms, double pneumonia with this COVID-19. That's when it becomes a struggle because you're already like really, you have 2 lungs that are effed up with fluid. Now it becomes a struggle, and people are getting through it. I've seen on the internet. I've seen some people in my circles that I know that are really sick. One girl from back home, she was in Dominican Republic and the casinos less than 3 weeks ago.
Whoa, yeah.
Yeah, like she's getting through it. She's getting through it, and she showed her medication, and she's like, I feel terrible. I feel absolutely terrible. And she made a video. It went viral. She was in the hospital. She's getting better, and it's like she has to take a lot of medications now. So,
well, when I got sick in January, it lasted all of February. I felt crap the whole month, man. And it took a while for this thing to go away.
Wow. And look, I mean, the only reason I went to the hospital is because I was leaving work like I normally do. I'm going to have my normal couple of beers at my tavern and some chicken wings, and I coughed and spit. And I'm like, wait a minute, I didn't have cherry candy. Is my tooth do I have a tooth bleeding? So I gather saliva in my mouth and spit, and I'm like, that's a problem. So I knew right away that it's either bronchitis or pneumonia. And I'm like, I feel fucking fine. I feel fine though. Like, okay, let me eat my chicken and drink my beer first before I go to the hospital. But I went, and they were like, you have slight pneumonia, and you're on your left side. Like,
well, I'm not sure if
have you been out the country? No.
I'm not sure if these numbers,
with anybody? No.
John, I'm not sure if these numbers are correct, but from a few sources I've heard, as much as 30% of people that get this virus don't present. Like any symptoms? At all.
I think it's
that's what I'm saying.
Yeah,
that's what I'm trying
higher
to say.
than that.
Like, that's weird. Like, look, man. Again, I didn't eat cherry candy. I don't have a mouthful of hot sauce. I don't feel sick, but I had a dry cough at the end of my shift. I just was like,
no loose
why am I
toothies?
coughing? Nothing. And I'm like, okay, you're rational, Sean. You know what? You already know what it should be. I don't have cancer. I don't think I do.
Probably not. No.
Okay. So when I cough normally, I don't know. It's time to go to the hospital, and I'm like, okay. And now I was like, they're gonna think I have corona. They put the mask on me, and they're asking me all these questions. And he gave me a breathing treatment. Then I started wheezing, and it was like, oh shit, this is wild, man. Nobody's gonna believe this is a true testimony. Like, nobody's gonna believe this. But like, I took 2 days off work just because I could. You know, if I have blood in my mouth and I'm coughing blood, I can't be around anybody. So I'll take 2 days off. The antibiotic worked. They gave me Afrin, which is nasal spray, and albuterol. I still have the albuterol. I'm hoarding it. You know, instead of 2 pumps twice a day, I take 1 pump twice a day. I need that to last because I don't get another prescription, but I'm fine. It's like, yeah, I feel I'm not sick. I don't have a fever, but yeah, people, this is real stuff going on out here. Depending on your body, depending on your immune system, depends on everything. Like,
Yeah, and I was just having a conversation with James. Don't forget, this virus mutates a lot. And just because I went through it once doesn't mean I can't catch it again. if it mutates, I can catch the second. I can catch it. Everybody can catch it again.
Oh.
So you have to be multiple careful. Like listen to Sean's advice. Clean and wash everything every day that you wear. If you're wearing a mask, wash it. Spray it with Lysol. Do whatever you have to do to kill the virus that may be around you, and keep it out of your house.
Hey guys, Buddy James here. I got a real life testimony. I have a real life testimony of having this disease, which or whatever you want to call it.
Technically, it's a disease, yeah.
Back in December, going on into January, and my entire work also got it. My parents got it. We all had it. So what we're all talking about here is, are we over the curve? I think the mass hit in December, January, February. So I don't know if we're over it necessarily, but we know for sure that it's probably been here a lot longer than we think. Most likely, around October 18th, 2001 or something like that.
It started in Wuhan in November.
Well, yeah, but it doesn't take long to understand now.
That's the thing I couldn't wrap my head around, because we watch movies, and in February they're like, oh, the coronavirus is in China, and it doesn't spread like a movie. It's already been here. That I talked to my cousin, the biologist, and I was like, there's something that doesn't make sense to me, because the way we're pushing it through the media that it's spreading, and now it's in America. No, it already happened, guys. Then I wrapped my head around it like 2 weeks ago. Like, wait a minute, it already happened. It already.
Hey, I don't think the peak is this month. I think the peak was last month.
I don't think you're even close to the peak yet.
No, we're not at the peak yet.
But he just said it. It's already been out. It didn't happen the way that.
You see, the way of a virus spreads is it spreads, especially in today's world where there's a lot of travel. A few people in an area get sick.
I'm in the battle zone of Michigan here, okay? I mean, if you look at the United States, they're like, Michigan, everyone's dying. It's like, all right, I knew this was going to happen. I prognosticated this, and now it's $1,000 fines if you disobey the orders, the law of the land. These constant acts that they pass. When you look at the acts, it's really strange how I'm glad that we had the sovereignty of state to state shutdown here. But that should have been how it is. And I'm glad that Trump allowed that to happen, but it should have actually been an executive order to shut everything down a lot sooner. And
obviously.
It's just, clearly, but it's like, Trump could have done that, but he did the right thing by letting state by state do it, because that's the most advantageous for governor to governor to move things from place to place. And I don't know, this could all be, what if we're all tucked in place because of the asteroids that are coming? I mean, you've heard of C19Y4. And apparently it's like 8 times the size of Jupiter or something. Isn't that going to disturb the...
the coma is 8 times the size of Jupiter. Well, twice the size of Jupiter, sorry.
So I don't know. I'm trying to get the facts. We tried to do it on the show yesterday. We had Tess on, and we kept looking to try to get to the bottom of this. But it seems like there's 3 of them headed at us right now, 3 different comets, and one just split up. So some shit's going down, that's for sure. And these comets apparently haven't been here since 300 BC.
Yeah, 6,000 year cycle.
Yeah. So, 300 BC? That's only 2,000 something, right?
I thought Comet Atlas had a 6,000 year cycle. It might be that these other comets have a shorter cycle. I don't know.
It's really hard to get to the bottom of these truths. And it's really strange because it seems like there's a lot of disinformation. And what could be happening is us in the stay in place order to avoid what's about to happen. what we talk about on our show so often, and we're about to see it in the skies. I mean, who knows? This could be some sort of an event that people already know about and the governments already know about. I mean, I'm not denying the fact that there's a virus going on at the same time, but that comes along with the comets most of the time too, along with the cometary
Usually
tail.
afterwards, but
Yeah, the orbital period for Atlas is 6,026 years.
that's cool.
Wow. So the Egyptians seen it, or maybe they went up to it.
The Sumerians and the Egyptians last saw this comet,
and that's maybe where we came from. No, I'm kidding. Let's get on, guys.
And you guys know most people.
Applegate or a white apple.
Is this 6,000 years ago? Is this one of the destructive events that reset one of the resets of humanity?
This could flip the Earth. I think this could be an Earth-flipping event, and I mean, we could just be bracing for the impact, and because world leaders around the world are already under the ground for what?
Well, they're saying COVID. But...
Even last night, guys. Last night, Venus was really bright. Oh, yeah, I see you. Hello, Miss Venus. Your hair is beautiful.
Yeah, Venus has been super bright for a long time.
Sirius was really close, but Venus was real bright. Like, yeah, hello, hello.
Very
but
bright.
Most people don't consider nature the way we consider nature. They look at 5G and go, "Oh, 5G! Oh my goodness!" They don't even look up above your head, 6 feet.
What if?
Yeah. Sean, last week I looked at Venus when it was a nice clear day, and I could swear I saw a tail coming off of it, a little streak coming off the side of it.
You said that.
Now it might have been my terrible eyes, my old eyes, but I could have swore that I saw a slight little smudge off to the one side of it.
Could be, because she's awfully bright these days. I'm like, you're usually bright, Venus. Yes, you are. So it's serious, but you're awfully bright, Miss Venus. Hello, you're awfully bright. You're awfully
What if
bright.
What if we intentionally broke up one of the comets already, and that's why it broke up? I mean, there's a lot of things coming at us right now if you look at it.
Well, I'm more.
Well, can you give us a list of the comets that are coming? We already know the one, Atlas. Can you give us the other ones, James? And I'll have a look at. I'll Google them, and find out what's going on.
That's the hard thing. We tried to do some of that yesterday, and it seems like there's a lot of information or misinformation, or amateur scientists finding this, and then like just this comet alone, the ginormity of it coming. If you look, they say that it's going to come in between a couple of the planets that are close to us, and shit, that could be the shitstorm that lights everything on fire with the cometary.
From my understanding, its trajectory will take it out just outside of Mercury and inside of Venus, and it will wrap around the sun and come out around the same area, between Mercury and Venus.
That's what we looked at, yeah. But that's really close for such a ginormous object. The object itself, I mean, I don't know.
Yes, we have to think of what's going to happen when it enters the ecliptic of the solar wind. We're going to see two tails. We're going to see the tail that from it coming in, and we're going to see a new tail grow from when it hits the ecliptic, and the ecliptic starts pushing away on it. We're going to see two tails.
Yeah, that's going to be sweet. If we can see it, I mean, if we have satellites that might be able to observe that part, that shift happens on the other side of the sun. So
looks like it's going to pass between Earth and Venus here.
Well, we're going to see it during the day before it wraps around the sun, and it's going to be visible during the day, apparently.
That one day?
Well, yeah, it's very close to us at that point. It's Venus
for a few days, I think.
Venus is actually quite close to us now. So,
wow, this is awesome. I'm excited.
Well, I'd like to know if what you guys were discussing and the other comet names. so I can have a look at them.
I don't know the angle because it's coming in, I think, on a fairly steep angle, but it will be passing fairly close to. It'll be coming in fairly close to Venus, like quite close. Within, it almost looks like it'll be within a planet's length of it, but it's not going to be that close because the angle's wrong.
It might light it up. Shouldn't it light it up? It should light it up. Like the auroras should go nuts. All this shit should go on like we talk about.
Well, yes, but only if they're lined up.
Storms. I mean, whether they're lined up or not, they're going to be close enough to cause storms. And auroral, like, probably, like, we're going to get a lot of tailspin off of this. And panspermia, who knows what kind of Egyptian shit this thing holds from last time being here.
Yeah, it's actually...
bottle of virus.
It's going to be coming in quite close to the North Pole, so it'll be coming in from there. So yeah, it's quite high. Not along the elliptic at all, I don't think. Let me just check here.
Yeah, I had a hard time figuring out the maps. I figure you guys would figure it out better than I could.
Well, no, actually, it looks like they did it here. That's for us. Thank you very much, people on the internet.
It says, I'm looking here at 3 comets in 2020. One is 2P Anki, 88P Howell, and C2017 T2. There's no mention of this one here that we're talking about right now. That's weird.
It's going to come.
I know, because it was just discovered in December of 2019.
Well, yeah, it's coming in from the pole. It's almost straight up and down, and it's going to come in, go down below the ecliptic, and then back up.
Right, crazy. and Randall Carlson and Graham Hancock, they talk about something hitting us from the pole region. A comet that was breaking up, hitting us from the pole region 26,000 years ago, and then again 1,200 years later, something happened.
We'll see it when it comes in, but when it goes out, we'll be even closer. On this way out, on the way out, if I'm reading this correctly, it will be quite close. Like, I mean, you can see it on the graph that I'm showing on the screen here, but I'll try to share it with you. You can see it.
Well, all I'm saying is I hope it's when it hits the ecliptic, I hope its tail doesn't touch the Earth. That would be bad.
Well, it won't, because of the angle. If you can see it here, I'll show it to you here. Makes it very clear when it's coming in. See how it's coming down, and it's going to go up and around.
That's the
really close, and then you can see Venus is
that's the animation I saw.
Passing Earth right there, so it's like going to be very close there, and then we're coming up on it. So I think it's going to be quite a nice show. We're gonna see it like that whole time.
It's going to be off, the tail's going to be off to the side. It's going to be like a great big L in the sky.
Well, wouldn't go L, but yeah. I mean, there'll be a dirt trail, and then there'll be a trail, so.
Well, there'll be a dirt trail coming
and then
up,
an ion trail.
Going up north, and then an ion trail for when it hits the ecliptic.
Still, this is what we're all about, the inner planets, so. So, Sean, you want to talk about some radiation? Do you? Or is Sean dead? Did Sean die? I hope he didn't die.
No, I was just posting the show on my Facebook, and then, telling my friend to just take a look at it because I'm outside and stuff, and I was a little late to the punch. And we're looking at possible causes of disturbances to the electromagnetic field of the Earth, and even things like viruses, yada yada. But yes, we should address the whole scare of man-made mythos, if you will, of the 5G and electromagnetic radiation, and we're gonna all die. 5G is gonna kill us all. Well, we're just talking about comets and interplanetary events or solar system events that could be a possible cause of viruses, changes to your DNA, etc., which most people don't even consider. They just don't even consider it, don't even look at it. So yeah, we should talk about it, Neil. Absolutely.
Well, I one of the things that I didn't know about it that should be a concern is basically normally we were all concerned about just the wattage versus the fact that we are basically water. And then you go into power plants and you determine how much how much you can absorb before you cook yourself or cook parts of you that you don't want to have cooked. But this, because of the higher frequencies, they do react with tissues differently. They dissipate more energy at the surface and penetrate less. So measurements will have to be across a smaller cross-section of the body. So that's something that we're going to have to pay attention to. But other than that, it's very similar. It's just amount of wattage that's affecting your body before it can heat it up, because it can't ionize anything. That's the most important thing. Because that's like what we call hard radiation. But I'm still looking for...
Well, yeah, for the same reason, Neil, when we go to get an X-ray, you use lead vests. For the same reason,
you'll be fine.
That when Dr. Peratt was doing synchrotron radiation experiments, they were far away, shielded, and looking through X-ray telescopes and what we'll call fiber optics for laymen. Yeah, that's complete. That's ionizing radiation. Gamma rays. This is not the same thing at all. But then the concern becomes, well, it gets hot, and oh my goodness, it's hot, and then that means it's going to kill you. And I'm like, well, again, in the Sapphire experiment, that chamber got really hot, and they're right next to it, and they're not shielded, and they're talking to us, on the shows, and they're not sick, don't have any viruses. So people have a misunderstanding of just some basic scientific and technological principles. Then, I guess that's where the fear comes in with people. People get afraid real fast and just don't have a real basic understanding of things, and just Google research and look at Facebook, and it's like, okay, that's not gonna allow you to be able to deduce things properly to understand it. You just won't. You just never will. Luckily, I had a radiologist in my family, so my cousin, a biologist, his father was a radiologist. But graduating, coming out of medical school from what we call now the great University of Pittsburgh Medical Center, who also are working on COVID vaccinations, and I've read those articles the last couple of days. I just wanted to throw that in there. Luckily I come from a family like that where I can just call Lifeline. Hey, can you tell me about this? Or even you, Neil. Hey, Neil, real quick, man, can you just let me know XYZ, a couple chemists. I always defer to people for understanding that, are in fields that still what you're doing in the lab and what you're creating can kill you. We've talked about that before.
This is very clear to me. The dose is going to be higher. They were worried because there's going to be so many more transmitters. That's an arguable thing, but skeptics should caution that you shouldn't conflate asking the question with merely asserting that there's a risk. We're still talking about a power and frequency that is still less than light. So if you go out in the sun, you're bathed in electromagnetic radiation that is far greater than a 5G cell tower. This is the thing. I mean, the sun will cook you. That's where you start getting, and that has hard radiation in it. The sunlight. It's like,
I mean, I've mentioned that in posts. Yes, I have. In the auroras and how it works from a layman's point of view.
X-rays, gamma rays, you're taking it all in.
Yes, thank God there's a lot of water, quote unquote, water shielding. and that's an issue. That's good because the atmosphere is good that way, but that only stops about like 1/3, 1/4. The rest, of course, you get certain frequencies because the atmosphere has water in it and ozone and stuff like that. But still, we got to be careful because people are concerned about the temperature and stuff like that. I totally understand. But because, I mean, they're going, part of the problem with the WHO declaration, World Health Organization declaration, it's focused on hazard and not risk. And it goes, for example, WHO classifies coffee and nickel and pickles as possible carcinogens. So
My mom has a question.
yes.
She says, when's the comet supposed to come? When's the apogee or whatever, or the perigee?
It's actually already here because we're going to be about the same distance from it the whole time, all the way till like for 3 months.
Oh, so we can see it. But when is it closest? Is what I'm asking.
It'll be closest, like just coming up soon, and it will be close again when it leaves.
Okay. Is it May that it is closest first?
I would assume April, like close.
Okay. Huh. All right. It would be fun.
That's a good one, Richard, about where they come from. I was wondering about that.
Yeah. Well, I was talking about this with someone on another YouTube channel earlier today, and I had mentioned that these comets, they come from planets throwing thunderbolts at each other, carving huge chunks of ground out of the planet, ejecting it into space. This is probably what happened during the clash of the Titans, and when Jupiter came and kicked Saturn out.
Now you're beginning to see what I'm thinking about.
This is the directions that the gods left out. The Egyptians say that the gods left us. This is the directions that these planets took when they interacted with each other and they were moving out of the outer solar system. It might have looked like they went to the Pleiades and then Draco, but they all went outward in the solar plane. It just looked like they were going to those directions, and that's why there's these places in the sky are so important to the ancients. This is my opinion.
Well, that's a good opinion. One of the things that I immediately thought of is that the orbit, when this comes all the way back around, it was 6,000 and some odd years ago, if you calculate the orbit. We should be able to back calculate a bunch of orbits of long-range comets. And there should be a point where a lot of them meet up. That will be where they exploded from. If you keep going back a few cycles, you know what I mean? Was it 6,020 years ago, or was it 12,000 and some odd years ago? Should be a central
point of origin of all of these rocks. But we have to take into account, when we get to that point, how much energy would it take to shove a rock this size out that far? Right?
Well, I was more thinking about there's going to be a slight deviation depending on how long they are, because the right-hand rule says that there's going to be a force acting on you slightly. So as we know that the comet's orbits tend to go in a butterfly pattern, where like Halley's Comet keeps orbiting slightly off every time, and so it basically precesses.
Right.
That's all I meant. So,
but what I'm talking about is these comets or these meteor streams tend to come from Draco, tend to come from the Pleiades. That leads me to believe that the planets went out in those directions.
Well, planets will be having constant
and-
interactions. The comets themselves only have the initial thrust interaction.
Right.
That's why they might be useful. I mean, for a time sink. And I think it's very interesting that this comet adds up to 12,000 years ago. It's 6,000 years as its orbit. So if it orbited twice,
yeah.
it could have been thrown out 12,000 years ago, which would go ahead with your theory. But if it was 6,000 years ago, it would go ahead with the other theory. So there you are.
Oh, well, I don't. We think that these last interactions between Venus and Mars may have happened as early as 6,000 years ago, right?
Well, yeah.
Well, it could have been this comet could have been part of Valles Marineris.
Well,
and then
possibly,
it's
yeah.
only been through once.
Well, that's what I mean. I don't know. But that if you get a bunch of them that are long-range comets and you calculate their return, I mean, Comet West is like 75,000 years or something, but others
and
are
see
like...
if their points
see if they converge, yes, at a certain place, yes. The longer the range, the better, because they have less chance of being disturbed on their way through again.
Right. Yeah, interacted by Jupiter or Saturn, yeah.
And we can't really tell because it will be somewhere near... Well, actually, that's very interesting because this would insinuate that it birthed somewhere near Venus's orbit because that's where it crosses near. You see?
Right.
I think that's very interesting.
And a lot as from my memory, a lot of these comets are in between Mercury and Venus. They scoot through there. A lot of these comets do. One or two of them, I think, are between the Earth and Mars, or a few of them are between Earth and Mars, but a lot of them are between Mercury and Venus.
There you are. I don't. I mean, and this gets right into what we're talking about with regards to charged planets. So, because obviously, having the charge around you, you're able to protect the planet from massive strikes. That's something that we never really had to consider. And we're also seemingly all heavy bodies on the inner planets. On the outer planets, they seem to be gaseous, which is also ridiculous. So it's...
Yeah, because the gaseous ones are usually the ones that are right close to their sun.
Well, it seems that way, yes. Or stars themselves. I like that someone actually...
It's more the rule than the exception from our observations of what we're seeing out there, that a lot of the solar systems that we've looked at, their gas giants are in close, not out far.
Yes. That does seem to be the case.
There has to be a reason for that.
Well, it lends to reason that we probably have a disturbed solar system. A merger of two solar systems, likely. I mean, that's not even controversial, really. I mean, we seem to agree conventionally, but they have nothing else to work with. So, but here it is. The question is that since we're also much closer to the planet, we're only like 600 volts away from the sun. In the atmosphere around us is only 600 volts from the sun. But of course, it goes to 500,000 volts when you have to go all the way to the surface of the Earth. And that, someone asked, what was that? I remember James was trying to describe capacitors and wanted to know a little bit more about them. It's more like a spring when you're talking about voltage. It's potential, it's pull. And they're want to crash into each other, but something is keeping that from crashing. And what that is has to be a positive force inside the planet that's pushing back. So at that altitude, the ionosphere stays there. And then there are layers of charge that it makes steps, and each one's like a cloud layer, and it reaches down into towards the Earth. And of course, we see it go the other way too, as it reaches in layers away from the Earth. So this is, and they're going these little steps because we would like to think that things behave. Well, this is the thing about plasma. They thought it, ideally it will behave like on paper, and there'll be a linear cross section of voltage from 0 to 600, but they found that no, it bunches up right near the edge and then makes steps going down towards the voltage. Like instead of being one giant waterfall, it was several smaller waterfalls. And so it's when you have this voltage, you have like a potential, a spring, or something pulling really hard. That's the current, of course, is the amount of flow there is. And we don't have a lot of flow. We have we might not have a lot of flow, but we have a lot of flow just depending on the calculation for the overall surface of the Earth and how much is coming in because of this leaking across the ionosphere. But it seems that they build up at certain places and then conduct all the way to the surface, and that doesn't seem to be accounted with the basic electrostatic theories. So,
and that's why the Earth is a sphere, because it
was made a sphere.
Well, yeah, because it's the best way to dissipate a charge.
It's the size of the sphere depends on the size of the current that made it, and that is depending because the size will be depending on the actual current, because it can't get any closer. It will basically shave off the planet to a certain size, and everything else gets torn away in dust, and then it is deposited. Like if you look at Venus, you can see exactly what I'm talking about, because Venus being a new body, according to Velikovsky, if we take a look, you can see it is. Let's see if I can get a whole planet size of it. There we go. There's a giant lightning bolt all the way around the equator of the planet. And the reason it's like that is, and you can see there's a part where it's not quite all the way around. That is probably where it was ejected from. So this lightning scarred surface is just massive. Now, if you notice, there's not a lot of craters there except for these little ones that are kind of mountainous. But if you go, yeah, they think there's volcanoes like that. That's so sad. Anyway, so you go look at the surface from 1975. Open image in new tab. Open image in new tab. Okay. These are pictures from the landers of 1975. And as you can see, the surface is entirely debris. Basically, everything above a certain point was lifted away, and everything below a certain point was kept. And it was etched severely. But there's no weathering, like except for electric weathering. And where did all these rocks come from? Like literally, just so many would have fallen to the ground. So this is what it looks like with a fresh planet just being made. Very thick atmosphere because of all the activity that just occurred on it. We're doing much better here.
All the hydrocarbons being created by the electrical interactions.
And look at the, giant marks. I mean, you could tell the difference between this and like what me and Robert went along and took a look at when we were looking at lines and rocks. Like there's a dike going across the surface, and of course that must be massive. And of course it's under enough pressure that it's, well, there's some of it. Look at this. This is a beautiful picture of what I'm talking about. There we go. That's, I mean, look at the flat pavement like rocks, you know? The whole surface was probably, you know, crushed to a certain level, and then it tried to, as the current dissipated, it got wider, and then try to pull stuff off the surface and breaking it apart.
Do we see any large valleys like Marineris or Grand Canyon in
well,
Venus?
Except for the entire thing that's going around the entire equator. But we don't know how deep that is because, I mean, they totally didn't expect to see what they saw here anyway, because they didn't think there was any light down there. Like, they thought the clouds were so thick you could not see through them, but I mean, the clouds were continually lit by constant lightning. And they think the metal, or the mountains are capped with metal because when they did marks on it, they thought they did radar images, and they thought that they had metal tips because there we go. See this? Yeah, that's a good picture. They thought that the top was actually covered with metal because the tops were so high up that they were basically constant St. Elmo's fire. So there was a corona on top of the mountains.
Right.
So that shows you a deficiency in sometimes what we do, because they're looking at something and they're saying, oh, okay, well, like, for example, they look inside the planet Earth and they see something traveling in the opposite direction of the jet stream going around the North Pole, and it's going in the opposite direction, okay, and it's going at a certain depth, and they think that they found flowing iron, but in actuality they've just detected an electric current, because we determine what materials these things are made of based on their electric current, on the assumption that the ground is neutral. They never tell you that part, though. Like, if you're a geology researcher, you would not look at the electrical properties of what you're researching. And sometimes you can't even tell what you're doing. Like, you're doing work on you have to figure out something that's interfering with something, and you're getting waves across your power line, right? And your good job is to try to remove those. Well, you have to sort of figure out where it's coming from first. And that could show you, well, I'll give you something a little bit easier. If you're measuring if you're doing a resistance test and you're measuring a circuit, right? And the battery's in the circuit, you might not even realize this, but there's a small resistance inside the battery. And that resistance grows as you drain more power from it. So you could be thinking, when you do the math, because you do the circuit, you put the battery in it, and you do the thing, it's only like 5 or 10 ohms, it's really low, and you're like, okay, and because it's drawing a lot of current. You're like, okay, I'm smart, I'm very smart here, and I'm going to do the math, and I do the calculation of the resistance, blah, 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 blah. And then I go and look at the real piece, and I realize it's not what I thought it was. And the reason it wasn't that way is because we often use what's called ideal circumstances. Like a diode is 0.7 volts. It's not. There's actually an equation depending on temperature and depending on a whole whack of variables what the actual forward voltage across will be. But on an ideal situation, we just say 0.7. And if you do the same thing with the battery, you do the math, you forgot to realize that the inside of the battery has a resistance that grows the more power you drain from it. So your numbers end up being wrong. And you don't know that because you're not trained for it. You just plug in your this is what happens when some people take their little handheld voltmeter and they stick it to two things and they think that they're getting free power. because they don't realize that once you hit a certain frequency, this handheld device becomes invalid. It can't measure over 3,000 RPMs or whatever. And this happens all the time. They think, see, I'm putting this much power in and I'm getting this much power out. I am making free power. And I'm like, no, hook up an oscilloscope that's properly tuned and you'll see exactly how much power you're getting out of it once you do the math. And that happens all the time because we allow ourselves to be tricked with our own devices because they work in 99% of the time, but not all the time. And that's the same with geology. You just go and, I mean, the guy who's looking for using the metal detector to find stuff in the ground doesn't care how it works, as long as it does. And the guy who's running geology doesn't know a thing about electricity is not going to not understand what's going on deep underneath the earth if you don't understand that. You're going to assume that you're seeing metals or something flowing or moving. And that's just the way it is.
Right. I agree.
And it's human nature. I'm not trying to, I mean, that's part of the thing that we're talking about.
They see what they want to see.
Well, so do we. I mean, that's the way brains work.
To a degree, but, show us something that's better, that's something that, you can prove, then we'll change our minds.
No.
Show
me something you can't prove wrong.
Well, that's what I'm saying, right?
Not quite. It's very close. But a lot of people say, this proves this. No, this is not wrong.
No, by experimentation, I meant. I mean, you have to show us logically and experimentally what you're talking about.
What our friend Monty did with the Sapphire Project, for example, when we were talking about that, he did it over and over and over again.
They've run these experiments multiple times, yeah.
Mm-hmm. So, and he even described some of the things where it's almost like you're playing like an art form, but you get to, and that's not wrong in a way, because in a way you're trying to hit chords and harmonies on a guitar. There's a math to it. There's a science to it. I can write formulas in musical notation, Not that you'd want to read them, and not that I'd like to do that, but I can, But that said,
circle of fifths.
I'm not a guitar player either, so my guitar playing will not be like Monty's, for example. So we and it kind of reminds me of the transporter on Star Trek. How it was, no, let Scotty handle it. He knows exactly where to move these 3 bars. You see.
The Tune Master.
Yes, exactly. Just thinking.
Well, I lost my train of thought.
I'm glad to distract you then. Please feel free to...
It wasn't you that distracted me.
Oh, okay. Yes, you are absolutely right, Jim. Assumptions in values and frames are easy to forget as assumptions. And yes, often people forget that. Like assuming space is electrically neutral.
Frozen electric fields and magnetic fields, yeah.
Assuming that all of our knowledge holds true and Hans Alfvén's original work in 1932 was correct, then yes, this is how electricity in space works. But that's why when someone argued on Electric Universe Theory on Facebook group, they were having a debate, and I was very sincere in explaining that magnetohydrodynamics is not real. If you don't, your math looks really nice, and that's why you want to use it, because it prevents electrical things from occurring, because it's just magnetic. But in reality, once you build a certain, magnets build a certain potentials in voltage, and it causes electrons to flow through them, that type of thing, and suck in. That's what's making the Northern Lights in the first place. We're just seeing the footprints of that type of thing. But what I meant is that there is there's a lot of things that happen when you start dealing with electricity. You start getting things like lights happening. Synchrotron radiation. You have double layers formed, as we were talking about the planet having them, and then of course layers in clouds, and then they build up potentials as you get voltage and gradients, and suddenly you have
Van
lightning.
Allen belt.
Yes, although that starts happening, and they start kicking up when they have to store energy. It's a convenient thing. But it's also the exact same argument they made a long time ago, saying that the Earth had closed magnetic field lines. And now, admittedly, all field lines are closed, but what they meant in this case was closed around the planet only. In actuality, our field lines go all the way to the sun.
Well, yeah, on the magnetic field lines that they call magnetic ropes in space, NASA calls them. We know them to be Birkeland currents.
Yes.
But the thing that I was going to say that it was that these magnetic fields that they say are frozen in space gives rise to a lot of electricians and electrical engineers thinking that, going by the standard model, thinking that magnetism is king. Is the way that the universe generates these electrical fields.
I've even had a friend who
it's the other way. It's the other way around. Go ahead.
I was wanted to agree with you. I've even had a friend who was saying the magnetic universe theory is more important, and I was like, see, the reason I accept that charges must come first is because you can have charges and no magnetic field. And you, if they're not moving.
As long as they're not moving. Yeah. That's right. If they're not moving, they're there, but they're not creating a magnetic field. There has to be movement of those charges.
They create an electric field.
And that gives rise to the magnetics of the universe. These movements of these charges along Birkeland currents that are connected between galaxies that radio astronomers now know 100% are there.
And if you think about it, the closer you get to the ground of the Earth, the more it has to break up the charge into separate currents to get to the surface, because it can flow very nicely into the sphere surrounding the Earth. We see that with, if you go high enough in using that Earth viewer thing that we were using before, you can see if you go quite high, you can see that the atmosphere is just spinning around. But as you go deeper into the atmosphere, layer by layer, it gets more and more complex. And you start getting these twisted forms and everything else. And of course, then that's where you get lightning and not sprites, because you can move things through the atmosphere easier if it's more charged, if it's more ionized. When you get really close, like within a kilometer of the ground, it's quite thick. I mean...
But I think sprites are part of all thunderstorms. We just don't see them all the time because they're covered by the cloud from the ground. We're trying to look up. Only pilots.
Here's the question, though. Here's the question. That I agree with on general principle. No argument there. But is there a condition where you can get sprites without getting the underlying lightning bolts? Like it just basically builds up the cloud layer and does not continue down?
Answer to that is yes.
And yes, it should be that way.
There are photographs of that happening.
Yes. That tells you that it's basically transferring to the cloud or vice versa and storing it and then dropping it to the ground or vice versa.
The next layer down and spreading it out to the next layer down.
And that layer is why the bottoms of clouds tend to be flat in the stratus clouds anyway. Because that's that layer. It's sitting on that layer. Everything above that layer is more ionized.
And that's why thunderheads punch through that layer and they get supercharged.
Same with volcanoes. They just pour this material up and then it hits a certain layer and then it just flattens out. Just like the thunderhead.
Atomic explosion, same.
Well, except when they're in space, I guess.
Well, I mean, we're talking about atmospheric tests.
Doesn't
that were done
suppress the flow,
40s and
James.
50s.
It stores the energy in the clouds themselves. The cloud.
Hence my name, Shockwave. I was
basically they store the energy in them, which basically builds up the electrical field between, which we notice in electrical storms, between the ground and the Earth at that place. So you're going to have charges in the ground racing to that point, and charges in the air also racing to that point. And they're opposite charges, of course. And they're going to be rushing to this one area.
But that's where they short circuit. That's where they short circuit. But the energy dissipates in that whole double layer around the Earth when these red sprites dump their energy in.
Well,
that's what I'm saying.
You could also argue that that those might just be a continuation of the current coming in from the poles that are spreading around the planet, because it goes in the poles and then actually encompasses, because it wants to get to the surface, but the surface is pushing it away, attracting it to a certain point and pushing it away because there's positive charge in the center, and it sits there and it can't get any closer. But other things, once you increase the voltage or do other things like lightning bolts and stuff like that, or sprites, they can get closer step by step by step, just like step leaders do. Clouds are a separation layer. Yes, technically these are all double layers because they are all dynamic. When I say capacitor, I am not really meaning fully a capacitor because, well, technically we don't even include the movement of the charges in a capacitor when it's discharging. But technically that does happen. So even a capacitor, when it's discharging and charging, must have movement. But that said, that's the planet itself is even more dynamic. So this is basically, a capacitor is what you would call a static double layer. Because a double layer is dynamic. It has moving charges, and these charges therefore have these breaks which can twist and go down towards the planet and so forth. They're not
depending on where the positive
solid.
and negative charge on the planet's surface is itself. Yeah.
Right. And there is technically a time limit compared to these numbers. Like if I calculate, like if you're looking at the Fairweather electric field, he's doing the volts per meter, blah, 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 blah. And then he's doing the calculations of the how much leakage you're having across this gap and stuff like that. Basically, the Earth will maintain a charge if it wasn't being recharged for minutes. That's it. But that's because it's so far away. The ionosphere is so far away. That said, though,
well, if it wasn't for the Birkeland current delivering constant amperage to the planet.
Right.
Yeah.
But what I was also trying to say is that might be irrespective of that. But what I meant is that if you put a capacitor that's not connected to anything on a shelf, it will be incredibly dangerous many, 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 many years later.
Yes. Yes.
There is nothing that drains it. If it's not, if the contacts are not drained, then it is fully loaded. And it will be fully loaded for eternity, for as long as I can recall. Like there is...
Well, as long as it doesn't break down mechanically.
The Earth will leak because the atmosphere leaks. But capacitors themselves, generally speaking, do not leak very much. This, of course, is a huge and very, very dynamic surface. So we're getting like the poles will have different polarities, and then the equator, and certain places will build up charge more than others, and that will attract
high places more positive.
Yes, exactly. And that's why you see clouds come over things and then suddenly they turn into clouds, like or they go away at certain places. It's not just dew points, and that's why we have such a trouble with weather, because we're not including electricity in the equation at all. Which is why we can't predict with any accuracy beyond a week, really.
Right. Yeah, and there are people that are looking at the Sun-Earth connection and trying to figure that out as we speak, which is awesome.
I didn't mean to cut you off.
I don't think you did. I was finished talking.
It's just that I was sitting there waiting. Who's going to talk next? No one talked. Okay. Well. I don't want to bore
Sound
everyone.
off, anybody?
Yeah, I know, eh?
Welcome to the Neil and Rick show.
Yeah.
Hey, Neil, you were saying that there's was it like a static capacitor or a dynamic capacitor? But like, what is there an example in electronics of a dynamic capacitor, or do we just use static in usual electronics?
Actually, you can have leaky capacitors that are made to repair themselves when they break. Which is like they're made to have a breakdown, but they can survive that breakdown. Basically, what's going on is that at the atmosphere can take so much potential, and then when it hits a certain limit, it must leak across that potential. Plus, there is a current that is literally being pulled to the equator to create the Van Allen belts. And it's creating the Van Allen belts there because this is where most of the charge is, right along the equator. Now, some people go, oh, that's where the sun is the strongest. That's why it's there. But I would probably disagree with that. And a capacitor can basically not be 100% perfect and can leak over time, just like a battery can discharge over time. That's why there's a shelf life to them. But usually when we engineer a capacitor, we make it so that it's perfect or near perfect. When it comes to the Earth, however, it's a sphere that's spinning in an electric field. Actually, it's traveling through an electric field while spinning and has its own magnetic field. And all of that, every single one of these charges is in motion, including the charges inside the Earth. So what might be holding the Earth apart would be something like a plasmoid down there could be rotating, which is entirely plausible. What is the Earth's double layers? Yeah, I'm reading that.
Yeah, he's asking about double layers. But aren't there like multiple kind of shells of those layers? I get with the ionosphere and with, like you're saying, underneath the Earth.
Yes, that is basic. The ionosphere is the strongest one the Earth has, but they're technically, you could say that there are layers inside of that layer, if you get my meaning. And when you go into the Earth, there will also be layers, because there has to be a point where the ionosphere is, the charges inside the Earth want to touch the surface because it's negative, but they can't get any closer because there's an ionosphere out there. And so both of those things are balanced against each other. Now the question becomes, and this is what I think, is if you threw the Earth into a different electrical environment or suddenly moved it much closer to the sun, for example, all those layers would compress, and the charges inside the Earth would also become stronger and move closer to the surface in exact opposite and equal fashion. And all the currents will be stronger. So they'll all be moving more. They don't stop, they just get stronger.
And the plasmoid would grow stronger as well.
Yes. So this is my thoughts on how the planet might have expanded or carved out a hole in the middle of it and turned everything around it into molten liquid or whatever. As
we approach the sun, and as soon as Saturn, we disconnected from Saturn's influence, all of a sudden we got fed this massive amount of energy from the sun. We were getting a little bit from Saturn when we were in the polar configuration. As we're coming up from the southern pole of the sun into its ecliptic, then all of a sudden Jupiter and Saturn, in disconnection, we connect to the sun, Earth expands. A lot of pressure feeding, a lot of energy feeding the plasmoid at the center, and it pushing outward, expanding the Earth from the southern pole region.
It's possible. there would be...
Well, because you've mentioned it many times that there's more soil on the northern hemisphere than...
Oh. I was doing so well, too. Nothing was crapping out. Then suddenly, boom. I should stop sharing my screen. That's probably has something to do with it. Try to make it easier. Okay, let's make it reconnect.
Brain, it's a bilayer.
There it comes.
And then within it's there's a highly folded membrane, all throughout the cell, and then there's separate organelles within the cell. So there's the nucleus, there's also the mitochondria, and they've got their own membranes going on.
Right.
And Raymond just sent me a video of the electrical interaction, the spiraling of when I think it was a chicken egg when it got fertilized. You should see all these little Oh yeah, I'll grab it. Hang on.
Yeah, link that in.
Because one of the first things that has to happen to a zygote when it starts to divide is it needs some polarization. So there is at first I think there's usually like a dimpling. That there has to be some distortion of this spherical cell that gives it a polarization, some orientation, which is similar to what we've seen on the Earth, I guess.
Yeah.
Blueberries, oranges, apples, you have grapefruits, pomegranates, onions, and you'll see that all of these have poles. They have a top and a bottom, and there's an electromagnetic field that's expounding from the inside.
That's something I'm very interested as well, because I see that in geodes. That's where I see it most. And of course, planets. I mean, that's obvious at that point. If we saw that if you were familiar with the dust that welders made, you would have no doubt that electricity is just, planets are just made electrically, because there's nothing strange about it in my world. The dust looks like planets, just little tiny balls.
Is anyone here familiar with uniform tilings or honeycombs?
Honeycombs?
Yeah, they're the periodic tiling of apices, which would be where the atoms are in a crystal.
Oh,
so
okay, like honeycomb lattice.
Yeah. And I'm not talking about a beehive hexagonal honeycomb. I'm talking about cubic honeycombs, truncated octahedral honeycombs, rhombic dodecahedral honeycombs. Well, all of these carry, in my study, they carry the ability to move a field. If you were to put a frequency inside of a crystal, it's kind of like a bubble field where if you change one bubble, as crystals grow, they have heat, and that heat changes the crystalline formation into a periodic tiling. But something I'm noticing is that there is actually a toroidal induction that goes along of energy wherever there is a morphing in the field.
Actually, you're probably right. One of the things that I've thought about this is the same thing someone was talking about birds on a wire, and it was, look, the birds are sitting in the Fibonacci sequence. And I was like, what if they're trying to make an antenna? And it sounds weird, but in actuality, you use a Fibonacci antenna to pick up all frequencies. And but the situation is that each space between, if each bird is slightly charged, then each space between each bird is charged in the opposite direction. You know what I mean? Like if you put two balloons together, your hair will stand on end. If you put, that type of thing. Well, it's very similar with regards to these lattice structures. You're very right. They will send frequencies, and they have a particular resonant frequency that they will transmit in electricity-wise, which gives them frequency. They have the principles of RC, reactance and capacitance. So they can basically be like a you can calculate it like you would calculate a if you were making a resonant circuit, you know, with those particular parts. But we don't do that very much anymore because, like, if you ever seen a radio where you had to sort of tune it back, it occasionally went out of tune and you had to sort of put it back all occasionally. If you've ever had a radio like that, that is tuning as done by a capacitor and a resistor. So you're getting basically charge can build up on one of the plates and slightly move it out of tune. Crystals don't do that. They are perfect, pretty much.
Yeah, yeah. Beautiful uniform tilings and crystals.
Well, what's cool about the crystals.
A lot of people think
Sorry,
these
I was
crystals...
I was enjoying what you were laying down, Brighton, and I just wanted to make a little comment. It's awesome to see that the crystals are actually straight lines, and because there are straight lines in nature, and I bring that up because there's debates among everybody, and is there lines or curves, and is there both? Why can't there be both? There's both, and there's multiple, all sorts of other fractal growths that are curved, and anyway, just wanted to say that.
There's a concept that I've been carrying for a while, that we live inside of a cellular automaton, which is like a cubic field or a honeycomb. But you take a look at neutrinos and how they stack to form an electron, and it's perfect sphere packing. And this kind of concept relates back to the crystal, because if you put at the center of each sphere, you can morph those into Archimedean solids, which fit in a uniform tiling. And it's fascinating, really fascinating, to see that neutrinos actually stack in a uniform tiling. We could say it's sphere packing, but I actually think that perhaps they change form to communicate different messages or frequencies. So this kind of concept of a pixelated universe expounded into macrocosmic levels, we might be able to see relations between planetary orbits and what's going on with electrical currents from a much smaller scale, from a scale that is an atomic consciousness, where each particle has its own free will to abide by within an algorithm.
Well, if I may be so bold, one of the things that I think is very interesting when you bring that up is I've often talked about the asteroid belt. If you ever looked at it or saw it, you would realize that there is a ring perfect around it, and just in the same fashion, except that each of these sizes are different. So each of the rock sizes are different, although within a variable amount of space, of course. But the spaces between each of these would therefore be the opposite charge of each of these. So technically then, all of this together has the rings themselves then can transmit, just like you were talking about the crystals, and should therefore have a quote-unquote radio frequency sound to them, much like the planets do. And
yeah, that makes sense.
And I think that might be a big step forward, because we should realize, why are these things crashing into each other? Why are they orbiting so perfectly? If you ever, I've learned this when I was at a hardware store. I was working at a hardware store. I know this is going to be funny, but they had all these really powerful magnets on one shelf, like on one thing, and I, being a bit of a dink, spaced all of them perfectly from each other, the same distance, and then and it was a wall, like an entire wall of these things. And then I just took one in the corner and I brought it to 90 degrees and I let it go and let it swing back and forth. And I watched it spread all the way across this entire wall as each magnet was interfered with the next magnet, because they were all being pulled back and forth because of gravity. But of course, they were being induced by the one I started. So it was basically, if you played around with anything on that wall, the whole thing would start moving. You couldn't grab a magnet without it, without like, I'm sure that somebody later, when I had pulled something wrong and watched them all go into one great big pile, and I wish I got it on film, because that would have been just great, but it didn't happen while I was there. So, but that's sort of the attitude, the ability to communicate electrostatic forces, which are generally instant, but of course moving the magnets, of course, takes inertia. So that's a bit different than what I'm talking about, but still similar.
It reminds me of bubbles and bubble geometry, where, and the only way that can be, where bubbles, you put you blow one up, and it has maximum volume, minimum surface area. Why does it have minimum surface area? It's because it wants to make that soap layer as thick as it can, so it can survive as long as it can. And that's a strange concept, that a bubble wants to survive, but perhaps it's an atomic property with atomic consciousness, where these bubbles are doing the optimal form to survive. And you
that might be attributing
together and one in the center, and you have a Rouleau tetrahedron. You put 6 of them together and one in the center, so 7, and you'll have a cubic bubble, which we think bubbles are spheres, but you start to get these kind of tilings. So in relation to your asteroids, it makes sense that the center of each bubble would be like an asteroid that pushes a magnetic field between other asteroids in the belt.
Well, it'd be static electrical field, but yes. Actually, you know what? I'm not even saying it's static. I'm pretty sure it's dynamic. I'm pretty sure that the asteroid belt sort of is like a ring current around the sun. But, but that's just because if there's a current flowing in one direction, there should be a ring current. But let's not dwell. I mean, we see these ripples in the rings of Saturn, for example. So I know that they occur, but along the same vein. But one of the things I thought about is the attributing of consciousness to something. As much as I guaranteed James would love this, and so does Buddy and a bunch of others. And I'm not saying it's not possible, but I often describe, like when I describe, say, a body falling in towards the Earth, an asteroid or something, or comet, and I say, and it wants electrons, and it wants to do this, and it wants, but it's just because these are the sort of the rules that it behaves under. It doesn't necessarily make it conscious. That's one of the reasons that we attributed the gods as capricious when we saw them, because it's just like trying to understand fire. No, she was very loving and kind, and then she blew up that city. We don't know why. She was just, being a bitch.
Well, here's a question.
Right, and if I could comment on saying here, if you take Brighton's concept here of bubbles, I do bubble sculpting and bubble geometry, and you actually take surfaces and you weld them together to create different types of bubbles. So doing the geometry of this, you really start to understand higher dimensional fields that create lower dimensional pockets and interdimensional pockets in inner space. Inner spaces, inner places. And these are what plasmoids consist of, and different types of plasmoids that we see, interstellar plasmoids and things. But you take what Brighton's concept of talking about these as bubbles and existing, and you can do the mathematics of the real world geometry of this. If you take into consideration Roger Penrose's theory of twistors and Hopf vibrations, if you look at it as fields of lower dimensional, hierarchical, and lowerarchical toroidal fields that become forests inside of the field that create the what Richard Merrick talks about as interference. These interference layers produce interference, and it's the constructive and destructive interference of these bubbles popping and overlaying each other, these fields overlaying each other. And this can all be described and is done in Maxwell's equations. And I never even got to the topic of the conversation yesterday. We were doing what the exponential is and the exponential growth of what they're showing COVID and how they use the exponential to lie on statistics with the guy that Al Gore in An Inconvenient Truth. They use the exponential.
You have to be very careful with statistics. And yes, with exponentials, they should only be used with exponentials in both directions. That's right. That makes things look like straight lines, technically.
Birkeland currents are exponentials, and Birkeland current, the mathematics of
but yes,
the Bessel function, the Birkeland current, it is an exponential. We never even really got into that yesterday either, because we were doing an episode on the exponential. But what I'm trying to get down at the fundamental of is these fundamental geometries exist inside of the exponentials of Hopf vibrations, which is these fields, which is completely shown and mapped out inside the Doherty set, and the set that Brighton did, and Brandt. And we have a lot of geometers that are mapping out this field right now. And if you see Alex Gray and his work, there is a field, and the field creates the forms that we are. And if we can start to understand what the field is better, then we'll start to understand what all the forms are and how they all use paths of least resistance and how they're all minimal energy surfaces, minimal energy configurations in and of ourselves. We're like perfect little wrapped up plasmoids, and we dance along the surface of the earth as circuits. That's all. Thank you for giving me
just as conscious as atoms themselves, or as planets or comets. That yes, we have the properties of free will to say, but I don't know if you've ever seen the movie Bandersnatch by Black Mirror. It goes to state that there are we have options, and they lead to different paths, and this leads to a concept of how time itself is actually also a honeycomb, not just space, but time. And in the fact that our decisions, if you take a look at a Mandelbrot, I'm getting somewhere with this, you take a look at a Mandelbrot and you start to zoom in, and as if every zoom is a frame where you're walking forward in time. And as you zoom into this Mandelbrot, if you zoom in one particular aspect, you're going into that future. If you change the direction where you look in one instance, which is a branching of the fractal of time, you change the outcome of the fractal that you're going to look at in the future zoom, or in the future of your choices in life. And I would call this a quantum property of choice. But is it possible for a cellular automaton to also have the ability of choice between certain options? I think it could be. I think we can create cellular automaton like that. We can create systems that have their own properties of choice, but they are limited.
Actually, yes, that happens all the time. In fact, one of the common things that is, I mean, Buddy will know this right as soon as I mention it. There's a video called "The Transistor Action of the Sun" by Dr. Donald Scott, and one of the reasons that's very interesting is because transistors basically are things that will with a little bit of energy will do a lot of energy. So you can let a lot through with a little bit. In that type of situation, you can also see where that happens to on the Earth and stuff like that. So it only takes a little bit for that to occur, though. And then errors will creep in, or little things. Right. We would call them errors, but like the other day we were talking about pulsars spinning around, and they do something. They don't tell you that they do this, but they do something called glitching, where they seem to stop rotating and then start back up again, which is ridiculous, of course. But that's an example of what I'm talking about. Basically, there's two planetoids in a harmonious relationship, a resonance relationship, and they're vibrating. And then one of them has stored enough energy over the course of all these times that it doesn't need to discharge this one time. It's cool for this one time, and then it will continue again. That is an example of what I think, in a nutshell, what kind of thing you're talking about, where it's like, I'm doing this for this much time, but I won't for this one time. And it, why did it do that? And people will, of course, if you're looking at this stuff happening in space, you would try to attribute meaning to that if you were on Earth and such. But
yeah, that's very fascinating to see that asteroids will stop as if they have their own. Well, it's built up charge, but we call a lot of things glitches. And when we were studying biology, like microbiology, there was a lot of commentary of how these tilings of proteins and all these other structures are wild and radical and disordered. But on a closer observation, like genetic chains and all these other things, when we're introducing genetically modified DNA into a substrate of genetic composition, we are not just changing a small portion of the DNA, we're changing the way that this story interlaps with its waves, because it has waves that expound inside waves inside waves. And when you change that little part, it actually changes a whole chapter. And we're seeing these periodic tilings, or these magnetic structures. Last night, I was actually chatting with a friend of mine, Chad Kushner, and he has a rhombic tricontahedron that he's put magnets on. And he says how it produces a small stellated dodecahedron field with the magnets that are vortexual. This
through
kind of
piezoelectric pressure.
Electric pressure, yeah.
Yeah.
This kind of geometry is found in capsid shells of viruses and geodesic domes in bacteria and nuclei and cell walls.
Oh, yes.
Everything we're seeing, what we're composed of, is formed of regular polygons and tetrahedrons and structures that are being put together
natural
like Legos
geometry.
And building blocks. And then throughout
we're made of natural geometry. Sorry to interrupt. That's my point.
Natural geometry, absolutely. And so when we start to think that this world is just on a whim, that there's nothing refined about it, there's a lot of people that see that in the scientific world. But no, everything fits with unison. It's, if you've ever seen a Romanesco and you pull it apart, you'll see that it actually creates a space-filling structure.
Mm-hmm.
It fills the space between the gaps with all those spirals. It's everything in our bodies in our human bodies is made optimally to work efficiently and to allow us more freedom. But
I love what you're saying, but I'm wondering if I can't see the screen, and I was just wondering. I shared some images while you talk. If Neil wanted to pull them up
I
in
see
the
that
chat.
there. I was actually looking for things that were similar to that. So, because what he was talking about, and I was going into anode tufts because I knew that there was pictures. I got some stuff from the Sapphire project on.
Anode tufts for sure. That's what's happening.
That's well, I'll try to look for a good picture of him if I can.
Remember that those anode tufts that we saw inside of the chambers that was being built, I think by Jacob Gable? Those were awesome. Krypton inside of a vacuum, the plasma.
Yes.
I've been trying to find that video for the last half an hour, Neil, with the spirals on the. I cannot find it. But it was amazing. It was on the surface of an egg. It was just recently done, imaged, that you could see these spiraling motions on the surface of the egg, and somebody was saying that it's an electrical interaction, that these waves, spiraling waves, are being caused by electricity.
Well, this right here is a natural ordered a bunch of anode tufts on the surface of Sapphire that's on the screen right now. It'll appear on your screen in the next 20 minutes or so if you're watching this feed. But you can also see, this is for James, if you were looking, you can see a shell around it. That's very similar to the shell of the ionosphere, for example. This is where one of the steps occurs in the double layer. And then there must be one down here that is basically attaching to itself all on the surface directly. Now, we don't have an even surface on the planet Earth. We tend to bunch up on the shorelines and all that kind of thing, and the mountaintops and so on, because we're not a perfect sphere like this is, or this is much smoother anyway. So these, and of course it's getting a much more current per cubic meter, if you know what I mean, because this is very tiny versus the planet. If you saw a planet like, say, Mars suddenly get covered in little dots like that, crap's going down. Crap is definitely going down somewhere. Like, I mean, this is probably, like, something's going to explode, because that's intense. That's a lot of energy there. We see one of these flashes on the surface of the moon every few years. You know, that's it. So, and each one of these, by the way, is, if you wanted to get a look at this now, it's probably on the screen now for you, if you're looking at the screen, but I'm going to now go and show you what looks like the Talvashar volcano. And yeah, that will do. Good. Glad it knows how to spell. Okay, and there's so on top, right there, should go to YouTube and actually look at it. Okay, so I'll actually share this with you, just to make it easy, because I think the computer will last. It's doing okay right now, so I'll share the screen. Okay, now there, you can, hopefully you see it. Now, I was showing, this is a Sapphire project that's on the screen right now, and you can see all these little tiny tufts all over it. Now, the volcano on Jupiter looks like this, and notice it has only one tuft, and you can see, because this is also well, there's probably another one down there that's trying to form, and another one over there that's trying to form, but it's connected into Jupiter's magnetic field, and these are pinching down on the surface, and it has to, when it does, it makes a little plasmoid and it barfs up. Now, this is only enough to light one of these, but it looks like this. And so each one of those look like that in slow motion. We have the ability to see it moving. See how we can see it's like they call it electron rain or something. And I'm being very, very sarcastic when I say that, because that's so terrible. But it's basically coming up, it's half of a torus. The torus is basically like on the surface of the planet. And material is being machined up and then brought back down. And a tuff is very similar to that, I'm sure, if we could see it in slow motion. But we don't. I mean, look what it looks like in just a snapshot. It's like just a perfect pink dome, but you can see through it. So chances are it is moving similar to that in real life because of the currents that are going through it. And of course, they themselves are little tiny tendrils that are made of basically filamentary lightning bolts at low pressure. I know that sounds ridiculous, but it's basically just fire. So it's carries current very well. And that's why it's doing it's maintaining the overall electric field, because that's what it's designed to do in the because it has a pole to it and stuff like that. But you would also see that it would have that would give it like the sort of positive negative aspects that make it want to bounce up against but not touch the ones near it. So it's very interesting when you start studying these things. And I hope that helps answer what some of these things might be doing, because the patterns of equilibrium are made all the time. And each planet must maintain equilibrium, electrically speaking. So that's why we think that the tails are a mitigating factor. They allow charge to be exchanged and therefore mass to be exchanged, so to speak. I know that sounds weird, but there seems to be a relationship between mass and charge that we're not fully aware of yet, but we can see it. We know it's there, or it seems to be. I didn't want to cut people off. I hope that was more helpful than cryptic.
I recently heard that a proton, the mass of a proton, is e to the power of 7 times the square root of e, more mass than an electron. So if you divide a proton by an electron, meaning how many electrons mass-wise fit inside a proton, it's e to the power of 7 times square root of e. So fascinating to see a transcendental Euler constant found in that.
Well, the question becomes, what is we don't even know what these things are besides their charges. We have to assume, unfortunately, that there's something that makes a proton different. Like it has something inside of it. But electrons seem to be just a charge, almost etheric charge. Like, the argument becomes, if you use two magnets and put them in the proper shape, and you can force current into one central axis, that's really neat. But you made that happen. So what is it that you're actually doing? Like, what is making that positive and that's negative? You're just using the downward flow of a magnetic field, or the potential that they make to make that strong, to make that, to make it work. But in the grand scheme of things, if I made two electron field, well, if I made a proton field, what the hell am I making? What is the protons? Are they just basically taking particles of the atmosphere and putting it together there, with stripping off the electrons from it? Is that what's happening? You see what I mean? Like, I think that in a lot of ways we've tricked ourselves because of some of the formula that worked, and we were like, yeah, that works good enough. Let's just go with that, if you get my meaning. And we're just scratching the surface, I think, in many cases.
This is an example of the uniform tiling and sphere packing with neutrinos. As they stack, they create an electron. You can see.
I don't even know if the neutrinos are real. So, but I'm okay with you so far. Don't worry.
All right.
I have to make. I mean, we don't really know.
I wanted to ask you a question, Neil.
Yes.
Earlier, you said you thought that comets and meteors were not conscious, but humans are. And I wanted to make a quick statement and then ask you further in-depth explanation on. I
honestly do not know if that's the case. I dance with that theory, or I've read Sheldrake. I know the idea, and of course James keeps me on my toes that way. And I'd like to think that the sun and planets could have consciousness, but the question is, do they? I mean,
right?
Yeah.
Well, we've taken, and this is one thing this really got me thinking is. We've taken rat brain cells, their neuron cells, and put them on a chip and made it capable of flying a simulated plane. Rat neurons. And that's extraordinary because there's no wires in there. It's just neurons on a chip.
That's amazing.
Now, that kind of makes a statement to me that I think there isn't much a difference between the consciousness we have in a brain and the consciousness a computer has. Just the computer doesn't have to worry about keeping a body alive so much. And it's also probably has stricter limitations, but especially with artificial intelligence coming out, it really makes me question if the electrons are truly what's conscious and that we are not, because
no, we're just a machine to run the consciousness.
Field.
Yes. The brain is just a giant electrical field with lots of potentials and transistors, so to speak, going through it. Yeah, very much so.
I've said it before. We're just a ham radio.
It would make a lot of sense to me that when a meteor start, as you said, it would keep spinning, but then it would have a charge build up, and it would be able to stop. I'd call that an act of its own free will, where it has enough energy, where accumulative energy allows greater acts of free will. With the sun, for example, it is constantly flaring and exploding on the sides, and all that is actions of, I would say, potential free will. It has a lot of choices of where to release that energy, but it decides to do it in this form, in this way, here, whether it's intentional or unintentional, perhaps from an electrical consciousness perspective rather than I am a whole human, I am an, No,
there's good at dancing around that subject. There's something to be thought about there. One of the things that I think about is what is consciousness itself, and trying to understand that, like if you watch Westworld, for example, one of the things that they lay out in their attempts at consciousness or defining consciousness is that they realized that you had to have something that did the work and then something that thought it was conscious on top of that, because you don't really pay attention to the math problem. Just suddenly an answer comes into your head. You have to train it, of course, just like muscle memory, but you're just getting the pathways familiar. So how is it doing that? And of course, we gauge that as intelligence, not the consciousness on top of, but the unconscious below is what we gauge intelligence on. And we don't even know, most of the time, we don't even acknowledge that even exists.
Well, my view on consciousness is this: consciousness flows everywhere, through everything. It is one of the many forms of energy that move through this universe, and that we don't know its exact frequency and vibration vibrational rate,
Mm-hmm.
but it has its own frequency and vibration rate, and it moves instantly everywhere in the universe, probably along a scalar wave type energy.
What it moves is to create cryptographic sets of understanding is form. Consciousness moves form. And that's why I think that the cellular automaton model is a really good example of what consciousness is, because in this example, it's not a certain frequency, it's not a certain this or that, but rather it's an algorithm by which all form must abide by. And when there is a cumulative properties in the field, say like cells, you can have a system, a whole organism in the cellular automaton that starts to live and breed and create. It's kind of like how you have in cellular automaton, they've shown how you have a very few cells, and those like 6 cells turn into, from an acorn into a tree. But instead of it being 4 adenine, trimine, guanine, I'm not sure if I'm saying those correct, but the 4 compositions in DNA, the 4 amino acids, rather it is 1 cell with a algorithmic property. Yeah. You can actually put different color cells that have different mathematical functions that interact with one another in a cellular automaton. And in that case, it would be like 4 properties of a genetic chain in DNA. And you will have acorns turning into trees. You can take cellular automatons and make them 3rd, 4th, 8th dimensional. They're not strict to the 2nd. It makes sense to me that consciousness is more of an algorithm which cellular functions abide by, and at certain times they have the ability to go down one or more than one path. It's a model for
depending on the type of star that that life is growing under. That star gives DNA its cue how to grow and be part of that system.
And fellas, this is why I even look at things now even everything you guys are talking about on a very fundamentally simplistic level, looking at the Earth as an Earth cell.
Yes.
I only need what's on this cell from the fossil record on up to be a part of this cell. It doesn't have to come from Ganymede. It doesn't have to come from Saturn. It doesn't have to come from Mars and any other hypothesis that we've looked at. This is the Earth cell, and due to circumstances and conditions, what is on this Earth cell through patterns that we see in nature, we're a part of this cell. It doesn't have to come from single cell organisms or anything of that nature. We look at the fossil record and look at nature and look at life, we can see the absolute pattern in the whole thing.
Not only that, we have to look at
it's changed, and it has absolutely changed.
Look at the elemental record too, the record of the elements on the planet. I think maybe we're living on the core of a star that had its massive atmosphere stripped off. It's possible.
Well,
and all
lots
the elements
of things are possible, but I don't. I'm just happy that we have an atmosphere at all.
We see the exact pattern, but the pattern is so simple that we may miss the pattern. Even from, how Wall and the guys show the geological ages on videos, and they show it. Let's look at the evidence we have on the planet, look at the patterns we see, and we absolutely know, and this is how easy it gets after a while. They say a woman has an egg inside of her, and the egg is fertilized. Well, reptiles lay eggs. They have a shell. A seed has an embryo in it. We've read things like biblical texts and things that say this man has the seed. No, a man doesn't have a seed. The woman has a seed in her. She has the embryonic sac in her. It's fertilized. It grows like everything else does. Even if you look at the geological ages, from what they say down to
we have
shrimp.
stamen in us.
There's big old shrimps. There's big old shrimps in the ground, and look at these big old, huge-looking snail things. Let's think for a second and look at it and say, hey, you know what? We could have come from that, and it could have grown, and then it changed based on the conditions and circumstances. Definitely with the different
photonic information.
Frequencies.
The photonic information,
it would change it. Sandro said it best, and I remember when Sandro was on the show, and he talked about incubators and eggs and Mars. Can we have kids on Mars? And he was like, well, Mars' electrical field is weaker, and I put these eggs in the incubator and manipulated the electrical field of one incubator. The eggs didn't hatch. They didn't. And these eggs over here hatched. That's it. It's real simple. But depending on your environment, depends on how things change naturally with frequency and environment electrically. Sure, because if we have a change tomorrow, and the planet would flip, and Europe will be like Africa, and Africa will be like Europe, which probably wouldn't happen because charge does come in through the poles and it exits out through the equator. I think you guys understand where I'm going with this. It would change the children you have tomorrow. Like, oh, they're different. They're not Neanderthals. They're not Cro-Magnon. They're not archaic. It's something else.
And they're not modern human anymore.
It's different. Now it's all different.
Have we taken a look at 5G and radio frequencies in relation to
we just talked about it.
Because I want to bring out a point on this. With the close down of Corona quarantine, there are 5G towers being put up by the Sprint and AT&T networks all over the country, inside of schools, which there was a lot of fight back in the schools, but now because everyone's quarantined, they can just put them right up in the schools. And there's already some videos out showing that late at night, there are companies going into the schools and police cars waiting outside, and they're installing them.
Well, now, that's where I would install them.
The point I want to think about this is that now reproductive cells do not have iodine sheathing. And that means that whereas my meiosis cells, or non-reproductive, do have iodine sheathing. So I might be saying those backwards, but the name of the cell. Okay. Now, the cells that don't have iodine sheathing, when they get hit by frequencies that are in a 30 milligauss or above range, if you're 3 feet away from a microwave, it produces 30 milligauss on approx. You can relate that to other frequencies like your cell phone. If you're holding your cell phone about 2 inches from your phone, it's a 200 to 300 milligauss frequency range. These 5G towers have a lot of different frequencies that they're putting out. Your smart meters on your house, they're shooting out, peaks at 500 milligauss that bolt through the whole house. And these properties, when you're in there are people that are EHS, electromagnetic hypersensitivity. My mother is one of them, and I live with her and I can't play my Xbox, can't have everything, it has to be hardwired to Ethernet because it actually disrupts her body. It causes her great immunity issues. She gets fire and itching through her whole body, headaches, all these other properties. And if someone has Bluetooth on, she will know. She says, can you please turn your Bluetooth off? It's not psychosomatic. She knows every single time. This thing about electromagnetic frequencies that
She'd hate my car.
Huh?
She'd hate my car. That's where I get my music from. Anyway, keep going. Bluetooth.
Okay.
Just a joke.
Yeah, yeah. You introduce these fields, and they are disruptive on myelin sheath health, and they also disrupt because these frequencies can penetrate through your skin and into your your neurons. They disrupt heart rhythm because the electrical signal gets altered or gets changed, moved, and it's these frequencies that were introduced into our body are astronomically higher than any natural frequencies that we see from the sun. That's like a 50th, a 100th of the frequencies that were in comparison to your phone or your Wi-Fi, all these other systems. It's completely unnatural, and I am really starting to wonder why these frequencies are unnatural.
I'm not sure about the unnaturalness of the frequencies, but I can assure you that
the amount of them.
Sunlight is giving 1,000 watts per square meter, and there's no telephone near God that will give you that much radiation. I mean, 1,000 watts. I mean, we use it to power houses. We use solar panels and stuff. Obviously.
I did some research on my own, and I was saying that the sun produces 5 and lower milligauss field to your body. Now, the information I've read may or may not have been incorrect, but it's what
I'm just sheerly going with intensity. Sheerly intensity. We're talking about 1,000 watts per cubic meter. That's how intense the sun is on the surface of the Earth at our range. I know it's weird, it's 1,000, but it is. It's 1,334 in space above us, but it's 1,000 on the ground because 334 go flying.
Okay. Well, the point is with this that I'm making, there's a high rise in cancer rates, in autism rates, and well, if reproductive cells don't have iodine sheathing, that's kind of pretty evident, but also perhaps there are a lot more chemicals introduced and genetically modified foods in our
I think it's more to do with the chemicals that have been dumped in our environment. The higher cancer rates and all of that and death rates and stuff have been happening long before cell phones came into being.
But they've also shown with rat studies that these frequencies boost cancer rates. They are highly carcinogenic.
It's probably true if the studies show it. But again, what doesn't kill you makes you stronger.
Actually, it says the scientific consensus is that wireless technology causing cancer is possible, but possible is not probable, and it's far from confirmed.
I've read some studies that were straight on evidence of this that are that I can actually bring up. It will take me some time to dig them up, but if I can find them again, I'll put them forth. And they were university studies that show an astronomical boost in cancer rates and cellular problems with rats when introduced to electromagnetic fields.
I'm actually now taking a look, so hopefully I can find it.
I just want to go back for a second to the failed star thought. If the Earth indeed, in fact, was created along the same Birkeland current as Saturn and the Sun and Jupiter and all of that, wouldn't it be classified as a failed star if it didn't ignite? And then if it was pulled into the influence of Saturn or first Uranus and then Saturn? Well, Z-pinch and plasma ignites and
Z-pinch
creates
is when
the
it
sun.
got made.
Or it creates a corona around it.
It seems that the only reason that, from what I can understand, and this is generally seems to be true, is that once the electric field of the sun encompassed all the other planets, they have to live off of its field. And they are no longer, no matter where they are, they're no longer suns. They are...
Once they're inside the magnetic field, they switch off.
Unless they happen to be quite large, and then they have a mixed magnetic field with the planet beside them. That's your pulsar or binary star system type of thing. So,
Right.
What about that bright bitch Venus? What about that bright bitch Venus?
well,
'Cause
that's
that bright
why
bitch
it
has
was
been
so bright. It was bright
Oh, she's
because it
in-
was absolutely young. Remember, because it was just barfed out.
She's
and it was
incandescent.
high. It had to bleed off all of the charge it had when it was puked out of whatever body it puked it out just 6,000 or 7,000 years ago, or however long it was.
Saturn.
Well, that's definitely the argument. I'm going with you on that one, but I don't know for sure. I try to be open about that because I've seen so many good things and I don't want to cut them all down. I'm looking for, I found an entire study on rats and 2.5 gigahertz electromagnetic fields and stuff. Anyway, sorry, I just happened to notice it here, so I was taking a look. And it's going through things like semen analysis. Ooh, fun. Maybe I shouldn't show it on the screen here. Hopefully this helps you. This might actually have something to do with the study you're quoting.
Yeah, and I still can't find that video of the egg. Wow, wow.
That's quite all right. It's fine. At least we got a chance to talk about 5G again. And we'll obviously go over this just to be sure, because I want to be absolutely sure, but I'll have to just check the data. That's probably best. Because I want to be... I know that, I mean, it's not sinister to go out in the middle of the night and hook things up. That's what I do. I used to do that all the time. Like when kids were on vacation one time, we went over to the the province next door and upgraded their entire system to the new, I don't know, it was from the 2.5 gigahertz to the 5 gigahertz ones, I guess. So we had to add twice as many because they're shorter ranges. So we had to put that in. And then the kids showed up. And I don't think they cared. Oh, hopefully they didn't. Just relaxing, guys. It's a beautiful evening. Sunny here, amazingly enough. And I only crapped out once on the video, which is very nice. Because I have a great big fan blowing on it. To keep the thing from not working anymore. I don't know what Jupiter is generating. I assume that it has something to do, like I know how many days it takes to, or how many years it takes to go around. But it's orbiting quite quick. I mean, spinning quite quick. Only like 9 hours.
Found it.
You did?
Yeah, MIT News. I'm going to give you the link right now.
Okay. I guess I have to watch this. Come on. Hurry up.
There you go.
Huh. Actually, it's very interesting. Yeah.
What else do we know that spirals?
That looks like the atmosphere of a planet. That's definitely an EM thing going on there.
Well, Birkeland currents spiral.
That's crazy. Look at that go.
Uh-huh. That's what I thought too. And then if this is small Birkeland currents inside the egg reaching up to touch the surface to give information to this, I don't know exactly what's going on there, but it's wow.
I don't know what's going on there, but wow. Well, I can hear you there, buddy.